In this challenge, I want to learn basics of data analytics in RStudio using just ChatGPT and no other resources. Let's see if we succeed. So it's day 5 of our challenge to learn data analytics in R using just ChatGPT, and we have used the data set which is built in RStudio, which is called empty cars, as was suggested by ChatGPT. And in the previous videos we learned how to plot histograms, how to plot correlation plots, how to get other types of graphs. And in this day 5, let us do some kind of linear regression, right, to understand what drives miles per gallon. Let it be our variable of interest. So let's go back to ChatGPT and let's ask to write a code to estimate a linear regression. So please write our code to estimate linear regression of MPG with respect to all variables in empty cars. And just after a few seconds we get the code, so we will continue using our R code. So let's copy it. And again, if you are familiar with linear regression, you understand that this code will run, but let's check it. So I'm going back to my original code. I don't need to load the data set because I have already loaded it. And you can see here that RStudio will use dot to include all the variables, right? And it specifies the data source empty cars, and it uses LM as a linear model to estimate this regression. So let's run it. So as usual, we will highlight these lines of code and use Ctrl-Enter. And you see that we get the results of this model. So in particular, we get the summary of the model and we get some variables. So let us ask ChatGPT to explain what does it mean. Let's say we are not familiar with these concepts. So what does it mean? Adjusted R squared 0.81%. And ChatGPT provides explanation. So basically it's not just for code, but you can also get explanations, right? So if you're writing your homework or a course project and you're learning that, and I think that's kind of the key here, that adjusted R squared of 0.80 implies that approximately 81% of the variation in miles per gallon can be explained by variables included empty cars dataset. And of course, it's true that it's quite higher value, but we shouldn't forget that it's a very small dataset, right? So we have like 32 observations, 10 variables plus constant, right? So it's not like really surprising that we have such a big R squared. And remember that adjusted R squared actually has a penalty for the number of predictors in the model. So if you have 2 or 3 models with a different number of predictors or covariates or features, then of course adjusted R squared will be comparable, right? So basically the model with the highest number of R squared, adjusted R squared, will have the best explanatory power. Let's now ask ChatGPT to identify which coefficients are statistically significant. How to identify statistically, because these are the only coefficients which matter, right? If they are not statistically significant, or in other words, not statistically different from zeros, then we cannot make any conclusions, right? So we only want to look at the coefficients which are statistically significant. So let's run it. And here it suggests to use a t-test, which is very reasonable, but it does not provide the rule of thumb. So it provides you the p-value, right? So we can choose a p-value, for example, more than 5% to identify insignificant coefficients, right? And p-values of less than 5% as statistically significant coefficients, right? So in our regression model here, if you check the p-values, you see that actually most of them are much more than 5%, right? And despite a high R squared, the majority of these coefficients are actually statistically insignificant, right? Because p-value here is much more than 0.5. So that's one consideration. But of course, you know, in statistics and econometrics, we often use this rule of thumb for these statistics. Let's check if ChatGPT knows it. What is the rule of thumb regarding? So let's check the answer. Yes, and we got it right. So you remember that the rule of thumb is if your t-statistics in absolute value in is more than 2, then it means that this coefficient is statistically different from 0 at a 5% significance level. And again, it's convenient to go back to our studio. And again, here you see that maybe the only coefficient which is marginally significant is this weight coefficient, right, which is close to 2, but still not 2. And again, remember that we drop the sign and compare the t-statistics to 2 without the sign. Let's do model improvement here. Let's ask ChatGPT to use backward elimination. That's one way to find the optimal model fit, by keeping only variables which are significant at, let's say, 20%. Code for MPG in empty cars to estimate linear regression, keeping only coefficients significant at, let's say, 20%. Let's be a little bit more restrictive here. And again, usually if you have a very large data set with a lot of covariates, with a lot of different features, at the first run you want to identify these key variables, so you may want to drop others. Okay, let's check if it works. Again, if you are interested, you can learn the explanation here, but we will just do practical test. So I copied that code, I get back to my regression for the model, and I run it, and actually I get the error. So let's ask ChatGPT if he can fix it, or she can fix it, or it can fix it, this error. Sorry, we got error. Can you fix it? Can you fix the code? Okay. It says the code was cut off. Let's try this new updated code. Okay, I copied it. Let me remove the previous piece of code, this one. And once again, I don't need to load data because it's already loaded, and I get the same error again. So in principle, you see that not everything works perfect, right? But at least some most important codes work fine, right? And you can estimate a simple OLS, but not sort of a more advanced OLS. So thank you for your attention, and see you in tomorrow's challenge.